Hi everyone, welcome back to my math tutorial video. Today I'm going to cover partial fraction decomposition. So what is partial fraction decomposition? So partial fraction decomposition is a process of taking a rational expression and decomposing it into simpler rational expressions that can be added or subtracted to get the original rational expression. And here is an example. I have 3x plus 7 over x squared plus 4x plus 3, and this expression can be decomposed into two simpler expressions. And as we can see that those two denominator are simpler than the original denominator. So this whole process is called partial fraction decomposition. And when to use partial fraction decomposition is when we want to decompose a complex polynomial fraction. And there are two different situations of a complex polynomial fraction. So the first type is, the highest power of the numerator is higher than the bottom. If in that case, we're using polynomial long division. So for example, we have x to the fourth plus 3x to the third over x squared plus x. So you see the highest power is 4, which is higher than the 2 here. So if in this case, we're going to use polynomial long division to split this complicated polynomial fraction into simpler expressions. And the second case is the highest power of denominator is higher than the top. So for example, we have x squared plus 2x plus 7 over x to the fourth plus x squared plus 1. Just example here. So you see that the highest power here is 4, which is larger than the 2 here. So if in this case, we're going to use the partial fraction decomposition. Here's the general techniques to solve the Here are the general techniques for you to follow. So now we have to follow 5 steps to perform PFD. The first step is we factor out the denominator. And step 2 is to identify what type of factors you get after the factoring. So here, type is highlighted, right? There are going to be different cases. Sometimes the factors can be, just like very simple. Let's say like a constant, like 2, or it can be like x. And sometimes it can be a factor that includes the previous 2 terms. So such as like, x plus 2. And it can be more complicated if it's going to be like x squared plus x plus 1, right? So here, step 2 is to identify like which type of factors. Okay. And step 3 is we split the original fraction into all the possible terms and assign variables for each numerators of those terms. And after that, we set the numerators equal. So the left equals the right. And also we need to keep, the same common denominator. And the last step is we solved all the variables that we assigned before based on the equations. And then we can plug in all those numbers, all those values, plug them back into, the variables, and then we can rewrite the fraction. Okay. So it sounds a bit confusing, but I have a few examples for you guys to practice, and I will go through that to help you build a better understanding of the partial fraction decomposition. And here I want to talk about 4 different types of the factors. The first type is pretty simple. It's just ax plus b, and a and b, the small a and b, are just constant. And here the a is the variable that we assign for this numerator, right? And this is the terms that, we're trying to split from the original fraction. So let's see, type 2. Second type is based on the first one, but here we have a power. There's an exponent here, so it makes it, more complicated. So depends on what number, what value you get for the k, we're going to have this expression. If k is 2, then you only have 2 terms, 2 expressions here. And type 3 is we're going to have a polynomial, and this one has a higher power. The previous one is just like the first power, right? The power of 1. And here we have power of 2. So if in this case, we're going to write down the same, this one to be the denominator. And here is the thing that you need to pay attention to. The top is going to be ax plus b. Don't forget to add a b here. It's not ax, because you have to keep going. You have the coefficient for the first power, and you still have to, assume a coefficient for x to the power of 0, right? So it's like ax to the first and bx to 0, right? So that's the expression for the type 3 factor. And the type 4 is that we have an exponent on the type 3. So this is like we combine the type 2 and type 3. So the value for the k will determine how many expressions that you're going to write down. Okay? And that's pretty much it. And we can move on to the example. So here's the first example. We have 3x plus 11 over x squared minus x minus 6. And here recall the type 1 is ax plus b, and the expression that we need to assume is a over ax plus b. So the first thing is we need to factor out the bottom, right? So here we have x squared minus x minus 6, and this can be equal to x minus 3 times x plus 2, right? So then we have 2 factors. The first one is x minus 3, and the second one is x plus 2. So look at the type here. This is the type 1, and the top we can make a for the first one and b for the second one, right? And let me complete the whole equation. So now we need to make the numerator to be equal, and also before we doing that, we have to find the common denominator, which is the original denominator here. That's pretty easy. So we don't need to change anything on the left. We just need to find the numerator on the right hand side. So here I will keep the same because it is the original one. And on the top here I would have a times, like, the cross multiply here. So a times x plus 2, and here the same thing is b times x minus 3. Okay, so now I can set the numerator equals the numerator. So I can make a new equation which is 3x plus 11 equals 8x plus 2 plus bx minus 3. And now I just need to simplify the right. So here I distribute a to each term. So here is plus 2a, here is bx minus 3b. So here, still try to simplify it. Combine all the terms, all the coefficients. So the coefficient of x is a plus b. And the constant is going to be 2a minus 3b. So we can see 3x has to be equal to a plus bx, and the 11 has to be 2a minus 3b. So now we can make a group of equations. The first one is 3 has to be equal to a plus b, right? And here 11 has to be equal to 2a minus 3b. Then just going to be a very simple algebra. So I can get my answer, which is a equals 4 and b equals -1. Okay, so once we find the value of those variables, then we can make the final answer. So the original function is going to be equal to 4x minus 3 plus -1 x plus 2. Or we can do a better way is we change the sign here. So this is the final answer. The first example is pretty straightforward and easy, right? Okay, so let's move on to the second one. So I have x squared plus 5x plus 7 over x to the third, and blah, blah, blah. And again, this is the recall for the type 2. So the first step is to factor out the denominator, right? So here we have x to the third plus 4x squared plus 4x. And we can see that the common factor here is pretty obvious. I got a 1x here, right? And then it's x squared plus 4x plus 4. So here is the final expression. So we have x times x plus 2 squared. And this is type 2, and the first factor is type 1. Okay. So let me copy down the original fraction. Okay, and here the first one is x. And we put a here because this is type 1. And for type 2, we have x plus 2 first. And top should be b. Or you can do a2 as well. So for the first one is a1. It doesn't matter. And we have a third term, which is x plus 2 squared. And we give also a constant. So I will just make c here, because I prefer in this way. So next, we're going to find the common denominator, the same as the original denominator. And the top for the first term is going to be a times x plus 2 squared. And for b here, it misses the x, so we get an x here. And also it misses 1 x plus 2. And c, so it has the x plus 2 squared, and the other one is going to be just x. So now I can write down the new equation for the top only. Okay, so how do we solve it? Actually, this is a very useful way to, solve this equation. We can make assumptions, right? So the assumptions based on what factors they have for their denominators. So for the first one, it's x. So I usually set the bottom to be 0. So the first assumption would be x equals 0. So let's see, if we plug in x equals 0, on the left, it's going to be just 7. And on the right hand side, the first one is going to be 4a plus b times 0 and c times 0. So just 4a. So a is going to be 7 over 4. Okay. And the second assumption would be x equals -2. And on the left, we have 4 minus 10 plus 7. So the first term is a times 0, so it's out. And here is b times, there's another 0 here, so b is out. And this is only -2c left. I will have, this is 1 equals -2c, so my c is equal to -1/2. And we're still missing a b, so the last assumption is just make a very simple number. So I will just say if x equals 1, because here I already have the a and c. So if x equals 1, I will have 1 plus 5 plus 7 on the left, and on the right is going to be 7 over 4 times this 3 squared, which is 9, plus 1, this is 3, so plus 3b, plus -1/2. So here, just by doing the algebra, you will get a b equals -3 over 4. So here are the answers. And here I don't have space to rewrite, but anyways, they are the values for those variables, and we just need to plug them into this expression. Example 3. We have x squared plus 9 over 2x third plus 6x. So again, to recall here, for type 3, we're going to have a ax plus b on the top. So first thing first, we're going to write down the denominator. So here's my denominator. And one of the common factor would be 2x here multiplied by x squared plus 3. And the first factor, 2x, is type 1. The second term, x squared plus 3, is type 3. Okay, so let's see. We can do a over 2x plus, this is gonna be bx plus c over x squared plus 3. And here, let me copy down the original fraction. And here we combine the two expression here. And the common denominator is going to be the same as the original one. And then the numerator is going to be a times, so it's cross multiply, so it's x squared plus 3 plus 2x times bx plus c. So we set up the equation for both numerators. So the left equals the right. So we have x squared plus 9 is equal to, so actually here we can distribute the a to the whatever in the parentheses. So it's ax squared plus 3a plus, here is going to be 2bx squared plus 2cx. And then we can combine the coefficient. So for the term x squared, we have the coefficient a plus 2b, and here we have 2c for x, and my constant is 3a. So now we can check. So for x squared, we have the equation 1 equals a plus 2b. And for the term x, here is 0, so we can say 0 is equal to 2c. And the last one is 9, the constant is equal to 3a. So now we can solve these three equations. So the first one we can get is c equals 0. And based on the third equation, we can get a equals 3. So then we plug 3 into the first equation. We have 1 equals 3 plus 2b. So we will have the answer for b is going to be -1. So let me rewrite this expression. We plug all three values into each variable. So this one is going to be x squared plus 9 over 2x third plus 6x is equal to 3 over 2x plus a -1x plus 0 over x squared plus 3. And then we'll simplify that, and we get the two final expressions, and this is my final answer. This is pretty simple, right? Okay, so the last example is gonna be the most difficult among the four. So I don't want to freak you out. I will just ask for the expression, like the general form, like how you assign those variables for the like each factors like that. And yeah, as long as you know how to set up the form, then all those algebras is gonna be pretty easy, right? So let's see. Again, for type 4, we have, a power here and exponent k at the end, right? So as I said before, the value of k determine how many expression that we're going to have for our general form. So let's see. So for the denominator, we have x squared plus 4 squared times x plus x minus 1. So here I already give you those two factors, right? So let's say the first one is type 4. The first one is just type 1. Okay, so now let's set up the general form. So let me copy down the original function very quickly. Okay, so as we learned before, for type 1, we're going to have a variable only, right? Just only one variable. And here for type 4, look at the value of k. So here's 2. So it means that we're going to have two more expressions. So the first one is going to be x squared plus 4. And after that, here on the top, we have bx plus c. And the next one is x squared plus 4. And here we have a squared. The top is going to be the same. It's like something x plus something. So here we have dx plus e. So it's pretty simple, right? So if here, let's say the exponent is not a larger number, if I change 2 to something like 4 or 5, then you can keep doing it. Like if the F, so it's going to be F, G, and this is going to be a third power, and so on, until the final one is going to be something to the 5th power if k equals 5. And after that, if you want to solve this problem, you can, go ahead to combine all those expressions, and you find the numerator on the right, which you set up that equal to whatever on the left. And for each x term here, we're going to set up the equations, right? So the coefficient of the x to the 4th on the left has to be equal to the coefficient of x to the 4th on the right. And keep on going that until you set up the equation for the constant. And then you just try to solve for each variable. So I think that's it. So we finished all the examples. And here I would like to wrap up all the stuff that I covered today. So as for the summary, I've talked about the difference between the PFD and the polynomial long division. Is all about the exponent on the top versus the exponent at the bottom. So again, the highest power on the top is larger than the bottom, then we do the long division. And if it's in the other way around, we're going to use PFD. And next, we went through the 4 major types of factors, type 1, 2, 3, 4, and also their general forms for each types. So try your best to memorize this table. It's gonna be really helpful if you can memorize it, or let's say if you fully understand this, you will be really, really fast on the exam when you have those problems. So I think that's pretty much for today, and I hope this video helped you build up a better understanding of PFD. So I will see you guys in the next video, and thank you for watching. Bye.